Hi, welcome to KDSS Tech Department. This is an instructional video on how to set up a Mig Welder. I'm going to go through the process of setting up the shielding gas and how to set up the settings on the welder cabinet itself to perform a basic weld in mild steel. I'd like to show a brief comparison between stick welding and MIG welding. For those of you that are familiar with stick welding or arc welding, the welding rod is the conductor for the electrical current, and so the welding rod is held by the clamp, and you strike an arc on the workpiece, and as the current flows through the conductor, it melts the rod back and eventually consumes the entire rod. You have to stop your weld, reinsert a new rod, and begin your weld again. Something else that's occurring while you're welding is that the outer jacket of the rod is actually burned off. That outer coating is a compound that turns from a solid into a gas during the weld process. The gas has a very important role. It originates right at the weld point and it shoves outwards, and it actually displaces oxygen away from the weld puddle, which gives you a more controlled puddle and helps to keep inclusion and air pocketing from occurring inside the weld puddle. On a MIG welder, this process is achieved differently. Rather than having a solid on the outside of the MIG welder wire, you have an actual gas that's provided in a tank, and it's fed through the middle of the welding whip, and then as you're welding, the gas is provided to you through the whip. So that's an important distinction between the stick weld and the MIG weld. An advantage of the stick welder is that it can perform equally well outdoors, where you may have gusts of wind interfering with the weld puddle. The MIG welder is much more user-friendly because the distance from your hand to the workpiece is closer. You have a lot more control. It's a lot easier to learn. Whereas the stick weld, your clamp is held way up here, and for people while they're learning, quite often controlling the stick and being able to move a puddle with control is difficult to learn, difficult to achieve. So that's an important distinction between the two types of welding. But they both essentially perform the same way. You're flowing electrical current through a conductor, and the electricity is arcing onto the workpiece, creating a weld puddle. You're adding some metal into the weld puddle, and you're bonding steel pieces together. A welding tank comes with a shutoff valve, and it comes with two gauges that are part of the regulator system. The regulator regulates how much gas flow comes out of the tank. I'm going to start first of all by showing the tank pressure. If you watch this gauge right here, as I open the valve, the needle is going to jump, and it gives you a bit of an idea how much pressure we have in the bottle. Right now we are at about 1950 psi, pounds per square inch. Quite a lot of pressure in the tank, which is why the tanks always have to be chained to some secure surface so they can't fall over. And anytime they're being shipped, you'll see a screw cap on top of the valve to make sure that it can't be broken off. 1950 psi is far too much pressure for the welder to use, and so this regulator device is used to meter out a specific amount of flow according to the needs of the welder. This device works in the opposite manner of a faucet. In fact, if you open it counterclockwise like a faucet, it comes off in your hand. What's happening when you're using this is as you screw it in clockwise, it presses against the diaphragm inside this mechanism. If you watch this needle here, as I slowly advance, you'll see some pressure start to climb, and we're looking for 20 CFH. CFH stands for cubic feet per hour. That's the flow rate that suits our welder fairly well. And so once you've dialed into that amount, you're pretty much ready to start setting the welder for the electrical settings and begin to weld. To set up the welder, there's two settings that you have to select and adjust before you can begin. One of them is the voltage control right here, and one of them is the wire speed right here. And there's various numbers on each of the gauges, obviously. To choose your settings, there's one easy option that the welder allows you to do, which is to rotate to an auto set, where it somewhat does the thinking for you. Learning how to set the welder appropriately for your material is a skill that should be developed, and so we're going to work with the recommended settings in the chart. Under the cover, if you open it up, go to the Weld tab right here, and there's a whole series of information that we have to work through to choose what the settings need to be on the welder. First of all, first column says, asks you what material you're going to be welding. We're working with mild steel, so that would be this section in here. Second column over asks us what type of wire we're going to be using in the welder. And all of the welding wire that we use is a solid wire. So now we are into this upper section in here for solid wire. The third column right here asks what type of shielding gas we're using. And as noted earlier, the particular shielding gas that we're using is a blended gas. It's a mixture of argon and carbon dioxide. So now we are into the upper section of this row where it's indicating a mixed shielding gas. The fourth column is asking for what diameter of wire. This particular welder can actually be fitted for 3 different diameters of wire depending on how thick the steel is that you're going to be welding. A smaller gauge of wire would be appropriate for thinner gauges of metal, and then as you weld thicker material, you're going to be requiring more voltage and more amperage, and in order for that to be able to be carried through the conductor of the wire, you need to have a heavier gauge of wire. We've got the welder set right now for 30 thousandths of an inch, which is 0.030 on this chart, and so this whole chart has now narrowed down into one row, which is 0.030, which is the second row down, and it works its way across like this. If you look across the top of the chart, there are a series of thicknesses that are indicated, and you basically need to measure your workpiece or the stock that you're going to be welding. Choose a thickness gauge or a measuring tape or a ruler or whatever works for you, and measure how thick the material actually is. In this case, it's 1/8 of an inch. Work your way across the columns. There's your 1/8 inch column. So you follow your 1/8 inch column down, and you follow your 0.030 30 thou wire row across, and where those two intersect, you are given two numbers. In this case, it's 4.8 and 60. Close that, and 4.8 for your voltage setting right here is a guideline. If you observe on the actual image, 1/8 of an inch content material is over here, yet the chart points you to 4.8. Keep in mind this is a guideline. It gets you a ballpark setting that the welder will function with. It will give you decent penetration into the steel. It will give you an effective weld. Once you gain some experience, you can then learn to tune the voltage settings accordingly to increase penetration depth on the steel, etc. The wire speed was given at 60, and so you set this rotary dial to 60. At this point, once you've connected your ground to your workpiece or to the bench, you're pretty much ready to go. I'm going to show you how to prep the end of the gun. We'll turn power on right here. Notice we've got power lights on. At this point, when I pull the trigger, I'm going to get 3 things. Voltage through the conductor, I'm going to get wire feeding to me, and I'm going to get shielding gas. And there's an advance on the wire, and I'm not sure if the audio picks up the gas coming out of it. You need to prepare the length of this wire sticking out of the gun. It's called stick off, and the Mig welding plier is actually 1/2 of an inch thick on purpose, and there is a side cutter fitted into it. Turn the cavity side towards the gun and clip off the wire, And there is the stick off that's required. It's exactly matched to the thickness of your MIG welder pliers. That will be the distance that you weld from as you're making your pass. You're going to be maintaining a 1/2 inch of stick off distance from the workpiece to the actual gun nozzle as you weld your material. Okay, so that basically concludes the setup for the Miller welders that we have here at KDSS. Obviously there's more refinement required as you develop your skills. You learn to adjust the wire feed and the voltage to suit the welding conditions that you're working under. But for a basic setup, the video settings that I've given you will get you started. You'll be able to make a successful weld puddle, you'll be able to bond metal, and hopefully it inspires interest and perhaps promotes a career choice. Thanks for watching.